In background, to be very frank, with the limited time, I will just try to highlight some the aspects and how we can at least on a say common side or on a public side. There are so many stakeholders are there. If you talk about the waste, mainly common public citizens, they are the major stakeholders. If they are not overcome, they are not understanding the concept. Whatever we do in our municipal corporation or any or academic institute or anywhere, that will be the failure. So that is the basic idea. So with this to only sensitize the thing, I just show some of the photographs about tickets, what is plastic waste, what is waste and everything. Right for the intake of the yes. That the it is not indicator. But you see that. Now you can understand this particular aspect also. So one side I showed the diagram of photograph from the brand. Here you can see it on the waterfall. So both are equally available. See, even COVID side or whatever waste we generated from the mask that went up to turtle. So that is also the thing, and this indicates the thing how fast that waste is just crossing and going into the sea, water bodies and land everywhere. What are the thing going to happen that we see discussed later on? Again, one more body. See, basically, if you see the 1/4 of the say this particular photograph, the upper side really it is a nice nature. You can see that, and the 3/4 of the say this photograph that is what the human what it made. This is the human's contribution. This is what above side is what nature and what is the human contribution you can see. That is the point. Let us understand. Here also you can see that again major contributor is what plastic. So this is what our culture. The second photograph I have shown the south is what having some plastic and all. Everybody is now aware. No need to talk about the details about that. They are just eating that plastic and because of their health is under trouble and it is in the problem. But I just want to highlight with the help of this. Yes, this is one more photograph. Now coming to the city side. So this is supposed to be a open canal or open channel or open drain. Supposed to carry some say maybe a liquid say waste or maybe a drain or say stormwater drain supposed to. But it is covered with so many plastic bottles. We are in the habit of using this plastic bottle every day. So that is what the things happening. Now it is when it is covered, just imagine if this is the story everywhere, what will happen? The possible approximately you will find that if this photograph is not collected as such, you can see again the major contributor is what plastic. That is the point. And that is the reason in 2023, the theme of the environment was build the plastic. That was the idea. See, this particular slide I intentionally added. See, this is what we have seen at the time of COVID. And this was, say, it was really, in newly social media, it was spread. So that is what, see, that old photograph, what we have done with the nature. Finally, we got the nature and we have to carry the oxygen, the oxygen and the, it's only a will not be directly connected with the plastic as such, but one can understand my idea. If you are playing with the nature, you have to pay it. You have to pay nature say, as a output, or you can say nature will take revenge, not intentionally, automatically. Action has got equal and opposite reaction. That's what people say. But here I am not. I am in trouble. Whether it is equal, I don't know. Our action may be. Maybe one time the reaction will be maybe 100 or we cannot measure also. Say Chernobyl, whatever the atomic explosions that happen, still they are measuring how much losses are there. Bhopal, still they are measuring. So that is very difficult. I think that particular subjects are totally different, but I wanted to tell you what are the effects. That is my idea. Now with this intention, see, but some of the city side. That solid waste that goes into the river, maybe into the water bodies. As a major part, I said it is made of plastic. As a bigger reason, See, whatever gets contaminated, it gets polluted. And then the big waterborne diseases. Here in Mumbai, and Mumbai, in Marathi we say, Vevichi Eko Pausara. So Vevichi Eko Pausara, but every year rain comes. But after that, this all these things come. So dengue, malaria are all there common. Maybe I don't be diarrhea, everything is common. Let us understand this is connected with the something waste and pollution of the water, contaminated water. See, as I say, the institute, they are definitely interested in some facts and figures. So facts and figures are also there. You can see that. Due to time, the economic burden of 36. We have done some case studies or some discussion about the after discussion it's happening every year. My point is what let us understand. I'm just trying to sensitize the issue. Vectors and see, we understood the what are the effect, what are the things happening by photograph, by facts and figures. But I would add on the say lighter mode on this particular slide. You can consider on the lighter mode. You find that food stalls are there, open food stalls are there, and all the girls and ladies are there. They are know that the pani puri is very tasty and upset. It's a better right. And then nobody goes into restaurant and take money. Sir, you right for me. So why? ऐसा होता है कि go to restaurant and we eat वड़ा पाव. That is on the roadside. Pani puri on the roadside. Bhel puri on the roadside. Why pani puri on the roadside is tasty? So this is on the lighter note. Some must be getting from there. Take on the lighter note. And really, on a serious note, we have seen on WhatsApp, we must have seen that idli vada wala, where he takes the water in. That we must have seen on the WhatsApp. So that on a serious note, please note that also. So that is the point. Let us understand. So this is, so I want to highlight the aspect of the waste management, the way effect of the waste and plastic. Plastic is a floating, and because of that, see, when you talk about the wastewater and all, management becomes difficult. The liquid waste management, again a separate subject. It gives another conference. It gives another conference. Organizer to arrange. Adam is there, they are there. Presentation. Coming back to the say plastic and waste. Social and economic revolution. Separate. The city side, as an urban planner, I can tell you, over a period of time, the urban population of the say India is increased. And over a period of time increasing. And whenever you find that the population of the city is more, the waste generated is also. Waste generated is also more. Because in the let's say minor cities, major cities, metro cities, just imagine the number of malls and number of other things, other facilities. And when you put everything automatically per capita waste generated is automatically. That this is an advancement. We are in the habit of what use and throw. We are in the habit of what use and throw. Say we are here, it is okay. When we go to the say particular say 5-star hotels and something new thing, we talked about waste, and then after that we waste too much of food. We waste so much of say that handkerchief and so many things. So lifestyle is Inside the auditorium, we talk about the waste management, we talk about so many things. And outside the auditorium, we waste so. So this is the thing happening. We better understand. And we are addressing that issue. My idea or my focus is what how we can address that. Let us understand the problem. Find that over a period of time, everything stakeholders that was nothing. Here's what I know. Just you can take the example from the senior people. But now, the entire my life, whatever number of pens I use, my son used in 1 year, rather than in 1 month, you can see. So that is what happened. In our time, it was easy. Purchase it, use it for at least 2 or 3 years. Just only build and use it. So this is what we can talk hours together about all this. We get to understand. Whatever the writings and all, Chinese, 50 rupees, 100 rupees, use, throw it, make it 50. It was not the terms and all. Can think about it too. That third is very, at least in India, you think after 5 years, after 10 years, microplastic. Because we have to still concentrate on this consumer product industrial waste. Microplastic. There is a dangerous effect on the not only on human but on nature, on other animals. So that is the subsequent. Maybe another discussion after for discussion on microplastic. We have, I have already told you the beginning. Garbage are there, waste is there, plastic material is there. These are the impacts are there. So some of the
Yeah, two will test, so maybe you can divide accordingly.
they are not there. So I guess those.
So we are type of 11, 10.
So human what plastic, what The aspects are there and we have to of the wildlife and marine. Those were fish eaters, those were eating fish. And then the fish is available in Mumbai maybe around 30 years back or 25 or 35 years back. That fishes are not available. So people are not aware of what's the this is not like Mumbai, just imagine world. So this is what happening. You know, scientific people. 1950 means what? I'm talking about the religious industrial growth. Basically, on this eight time that day, the exhibition of plastic is so there is it is okay. So they want also it's a business act finally. So they will say how the plastic the speaker they will say how plastic and how so many people exhibition. So many people are going to come. It's a business. We have to understand that. Sure. But the way as a landfill and will carry that. Say we are talking Mumbai it is, but we are worried about what where dumps, how to dump. The Devnar and all that dumping spots are already built. They exhausted. So there is a problem. So now let us solution for that. The segregation is the major key. So if you want to go for recycle, so segregation is the this is our duty that we should convey all these messages to the common public. What the general public or common public they understood plastic. But you will find that I have shown so many times. So if I am delivering the lecture in engineering college, I will talk still more types of plastics. Still, I will talk still more types of plastic, but I am in a management district. So I am limiting them. I can show you then what are the organic structure of that particular plastic. So I am limiting that. So for it is you see that if the good bottles are there, is a properly manufactured bottle. On the downside, there is some the symbol is there. It indicates what plastic is. The good part is what after looking to the bad part, the good part is what majority of the plastic can be recycled. Majority of the plastic can be recycled. Only thing is what proper segregation is required. So this is the idea. We are doing with our segregator or the NGOs and all, and we are trying to segregate all that plastic. segregation. Trying to avoid the ethnic, just trying to go to the. Think that 1 to 3 types of plastic it will be a problem because that material is different. It is different. STP is different. LTP is different. It is different. The characteristics are different. Not getting together. So that is segregation. Very simple and one can understand. We find that so that incentives are required. So, in India, generally what happens? Either you need incentive or you need data. Is it true or not? There is only one. Otherwise, if you say nature, beautification, nobody. So either incentive or that, we want to find out. Yeah, something. So that is the point. So I can use number of examples. I say now incentive. I will give the example of it. Say helmet is a requirement for trade. So you find that the motorbike, the boys are there. Motorbike, the person who is driving that at signal, he see that there is a some person near that tree after that policeman. So once he observes that policeman is there, he takes that helmet and put on the head and crosses the signal carefully. So no challan, no penalty, no danda. As the signal is crossed, he takes the helmet out, put on the mirror, because mirror is more costly than this. Right? That's mirror is more. That helmet is for protection of the leader. So let us make it simplify. Why some confusion? Let us direct path, simple paths. What is the management? So this is what not effectively implemented, but it is started. If you see the good manufacturer are there, plastic bags and all, you find that they will right there. We will take this bag, return with this rate and so many things. Actually, this is started, not properly and thoroughly implemented, but started. So this is also required. You are done 10 hours back. Okay. So that is what previously we used to carry that 10 hours back would be in the market. Nowadays everybody wants stick the and we carry our say in our say Mumbai or say Maharashtrian culture in January we celebrate Holi. That for 2 months they celebrate. I always tell them, hey, why to give some plastic utensils and all? Better you give some canvas. That is helpful to the nature. You find that now in my vehicle, my water bottle is a proper water. I am cancelled. I have already cancelled that water bottle. Let us talk about the advantages of copper water and make insist that use copper water. So that automatically plastic water will go. Talk about plastic and plastic. Let us talk the advantages of the power. So how to convince that is the you find that all packaging materials are of plastic. Vision. Go for some plastic say bags, and they have written that it looks like plastic, but it is not plastic. It is not plastic. So that is possible. Yes, plastic. Yes. So we already do that by this. In some packaging material, we can take that. Take plastic. Very good. Very good. This is what the nature basically. See, if you see crow, it is taking all waste. Very useful and useful say you can say the species or you can say. So that is so such type of enzymes are we have to just motivate or we have to just develop the situation if we can get such type of enzyme and that is what we want. Yeah, it is only say example, it is theory. Then I can tell you, Sweden, they convert their entire waste into industry. And everybody is where they, as a citizen, they want that their the school bus for their children is running on this particular say, energy. It will come only if they provide the waste. They are facing the problems of the face. They are ready to import the waste. They are ready to import the waste. Please listen. Now they are very unlucky. They are not our neighbor. Otherwise, they have supplied waste and waste. Please understand. See the lighter mode and understand the serious mode. That is what my way of thought. I was very happy. They were not ready to use that thermocol say place. They said it is not good. That lady, which is uneducated, not even 10 pass, she told me, very nice, not to talk about our marks. That is what required. So, Pancha hai. This is what the NGT is also. connection. Or it will say, motivate our students and children to go on. Even say, madam, we can talk or we are doing it. We are just trying to focus on school children because they can teach to their parents. So this type of lectures only, I was very happy that they talked about in their own language and they said we will use Patravali. So that is what the word we are using here. So I was a jury for them and I was to assess their work. I was so happy I just selected that particular group only because they started using this. They, 300 years. Oh, 300. My initial photograph I have shown. Please understand. Because we are taking 10 rupees quarter, 15 rupees quarter, and then we do it, maybe 20. But it will take 300 years to become. I think, good news for you. Conclusion. Plastic waste. Conclusion. So with this, thank you for taking the involvement, maybe through body language, eyes. There is no point having so much of crowd. Okay, so thank you.
Like to call the doctor's name on the stage now.
Sustainable coolant oil for waste minimization. So our objective is to reduce the and so minimize the hazardous waste and secondary life exploration and cost efficiency. Our goals is adopt water-sol, integrate water-sol as a sustainable alternative coolant oil to traditional coolant oil. Reduce the waste generation and improved performance for the missions and cost reduction and also carbon footprint reductions. These all we are going to achieve through water-sol coolant oil. This is our process flow chart. We are making bulk materials, handling walls, stainless steel walls, cast iron walls and accessories. We are purchasing raw materials, stainless steel, cast iron and mild steels in form of sheets and rods. We are doing machining operation like milling, drilling and turning operations. There we are using the coolant oil to reduce the heat and lubrication, to increase the tool lubrication and increase the tool life. There earlier we were used traditional coolant oil. The traditional coolant oil we can't use the demineralized water. Our tank capacity is 208 liters. So every month we are using 208 liters. The 208 liters every quarter we are removing from machine. It is going to hazardous waste. So we decided to change the traditional coolant oil to use the demineralized water and water soluble coolant oil. So this water soluble coolant oil, we are doing the filtration system, which is attached with our machine. And so we are filtering this coolant oil. Again, we are reusing the to machine. So this coolant oil, every quarter only we are taking back. Otherwise, we are filtering and we are using again to the machine. And also we are doing machining operation like milling and boring. there are some scrap material waste generation will come. The scrap we are collected and we are returned to the foundry for melting purpose. They are melting the raw materials. Again they are giving the finished good to us to reduce the waste. This is our Mazak machine. It is called HMC machine, horizontal machining center. This horizontal machining center is a high speed machining and integrated with automation. And we are putting 160 kVA UPS to uninterrupted power supply, and all programs we are executed through HMI, human machine interface mode. We are using cooling and lubrication strategies. We are using the demineralized water with water soluble. That pH value we are maintaining 5 to increase the lubrication level. This is common waste coming from our milling process. Removal of excess material during milling results in material loss, contributing to waste. Efficient tool pass and optimized cutting parameters can minimize this loss, and dust and chips will come milling operation. So this we are controlling proper dust control measures such as local exhaust ventilation for essential for waste management. And during this operation, we received some scraps and offcuts. These offcuts and scraps we are collecting separate bins based on the materials. We are collecting every month and we are disposing this to our foundry. Foundry, they are melting the raw material and they are producing the finished goods. This is coolant and lubrication waste. This coolant is basically we are used for milling and drilling operation to reduce the friction and heat. Implementing strategies to minimize coolant consumption, 200 liters per quarter, and proper disposal or recycling of used fluids are essential. And this we are achieving tool wear. Milling tools have a finite lifespan and wear out over time. Timely tool maintenance and monitoring can extend tool life, reducing the frequency of tool waste. This is our machine, and so scrap, it's like a boring scrap and cut plates like that, so scrap will generate. This is our raw material scrap generation. Our raw material stainless steel 1000 kg per month. On that we are getting scrap 100 kgs. Cast iron we are doing 5 tons. There some scraps will come, that is around 500 kgs. This 100 kgs and 500 kgs we are giving to our foundry for recycling and giving the finished goods. This is our sustainable coolant management strategy. We are using overall coolant capacity 208 liters. Earlier, this 208 liters, we used full coolant. It is a traditional coolant method. Now we changed demineralized and water soluble coolant. Here 104 liters we are using water and 104 liters we are using the coolant. This 104 liters demineralized water during operation it will evaporate. Earlier it will not happen. Now that coolant consumption is reduced and that sludge hazardous waste is reduced and our consumption, coolant consumption also reduced. So we introduced new recyclable coolant composed with demineralized water. It is called the coolant Strub Stabilo Cut Ultra B. So this coolant we are using we are doing the filtration and we are reusing. We are implemented along with machine some automated coolant recycling process. There the coolant oil filtering again we are giving, again we are putting into the machine. Earlier is the coolant waste is from 350 liters. Now the coolant waste is 140 liters per quarter. This filtration system, there is some filter paper we are using, that is hazardous waste That filter paper we are collecting and we are disposing through Andhra Pradesh Pollution Control Board approved vendor for recycling purpose. So this coolant oil is benefits is reduced coolant replacement frequency, extended coolant lifespan, and cost saving. So carbon footprint, we are using the stainless steel raw material 1000 kg. Now we reduce the 100 kgs scraps from the raw materials. This is our circular economy optimization. We are using the precision machined with advanced technology, and we are using now sustainable coolant. This will affect the machine performance and reduce the hazardous waste. Again, cost saving. Thank you.
Thank you, thank you.
Thank you.
Next, we have scope 2 carbon footprint reduction in an MSME manufacturing pipes reports. Okay, he's here.
Morning to another present here. Project from Trinity College, Chennai. And we today's topic is about carbon, scope of carbon footprint reduction in MSME manufacturing pipe support. I wish to organize this British Council Impact on the Global Global Partnership Industry Academy Cooperative and 2023 by ISWMAW Business School UK and Industrial International Society for Waste Management and Water India. Carbon footprint in manufacturing operations, they have identified high consumption areas where pinpoint energy intensive processes were identified and scope to carbon reduction target and minimum scope to carbon emissions have been identified and sustainable integration embedded with the environmental goals in corporate secretary strategy, operate technology, streamlined process for reduced energy use and corporate social responsibility has been enhanced with sustainable practices, innovation implementation has been adopted appropriately technologies regularly and compliance with current and future engineering standards. The objectives of this project is just to reduce the emissions now branded feed and produce scope to carbon emission by renewable resource. Plan to utilize the large room area to captive solar power from internal operations in particular emergency. The problem summary of this is I2 carbon emission. Carbon emission is highly affected in this area, which has been concerns with environmental and reducing natural waste and operational impacts and economic challenges. Causes the reasonable responsible energy management is due to carbon emissions, we have been facing climate changes and rising energy costs and environmental contributions and operational goals. The effects are summarized there. The effects of this project have been summarized there. Scope to carbon emissions and not savings, environmental stewardship, availability, regulatory combinations, and innovation and technological advancement. These are the general overview of carbon footprint. When carbon footprint reduction is critical component of global efforts to mitigate climate change and transition towards more sustainable environment. Minimizing the emissions of greenhouse gases primarily focuses on the carbon dioxide emission associated with human activities. When we have been implementing the carbon footprint reduction, the advantages of carbon footprint reductions are listed, which is primarily listed as this. These are the carbon footprint translations. Before installation of solar rooftops, the particular efficiency has been utilizing about 99 kilowatts annually, which is from wind power. And after installations, the carbon emission, both solar emissions, solar installations, the carbon emission is about 32,150, and they have been generating the monthly solar emission of 99,000 units, which they have been used for their houses and exercise for this. The benefits of this carbon emission reduction have been achieved. Nearly 48% and confident. Energy savings and financial gains are being achieved. The intangible benefit is they can save electricity saving, innovative culture applications, and the overall conclusion of this project is object clarity, more objectives including print lanes, allowing scope to emissions and realizing financial and design through solar power utilization and writing process initiated fueled by higher awareness of sustainable energy and commitment to the environmental responsibility and to design as operational efficiency. We have also like tangible, intangible benefits and forward thinking impact. The project serves as practical and forward thinking demonstration of organization commitment to sustainability and responsible energy management, contributing to a cleaner, greener world, and setting a positive example of other in pursuit of resilience and sustainable future. Thank you.
Now let me build the British economy.
Yes, sir. It has been inaugurated by the British Council. The solar power installation.
Project.
This project has been installed by British Council.
No, this is what the specific industry that they face. That industry. Yeah,
It was not there. It's like a.
yeah. After India, the going down project, this has to not utilize and install. Then for inaugurating this solar plant, British High Commissioner from Canada obviously came to the areas inaugurated. That photo we forgot to right.
Okay, thank you.
Thank you for the presentation. Next, we have adopting circular economy, the evidence from train tech infrastructure case.
Good afternoon, everyone. Myself, Venkata Maheshwara Machina, representing GATM University on the case of Trinitech infrastructures, in which adoption of circular economy took place. In introduction, SMEs are majorly producing carbon emissions in different ways. So we are trying to make a small change to reduce the carbon. We went to Trinitech infrastructures, which is a SME, structure-based structural construction SME. We went there and collaborating with Trinitech infrastructures, we made action research to implement eco-friendly practices. The findings insight into tangible benefits of circular economy, filling gaps in existing literature while contributing to practice. Our need for study is to SME sustainability challenges. Our SME business model should balance both environmental and environmental impact and productivity, and optimization of energy consumption also directly goes to carbon emissions. And these are our aims and objectives of research project: to identify energy intensive processes, to access current energy consumption in each process and benchmark some of the processes by understanding all the processes which has been going in the industry. By using all this literature review, we found a way to define all the processes, which is Six Sigma methodology in DMAIC methodology, and we made this. In our methodology, we defined production operations and collected data. We analyzed the data and improved the process, and again collected and analyzed the newly adopted process data. These are our action case. This is the process flow, conventional process flow chart. For this SME majorly does welding. So this is the process which operations are measuring, marking, cutting, beveling, grinding, and welding. We have gone through this methodology and optimized it by suggesting this plate beveling machine, which is a process of automation. By suggesting this plate beveling machine, we have cut down the process by eliminating cutting process. Basically, cutting has been done manually by the workers by using gas cutting machine. In that way, we can also reduce the gas consumption and the carbon emissions which are directly producing from the gas. This is the data table we used to collect the data from the workers. We collected two types of data, which is primary data and secondary data. Primary data has been collected from the direct operations and the workers working hours. And secondary data has been given by the SME to ourselves. How many meters of weld they welded in past 3 months of time interval. By using this machine, this is the only data sheet we got. We have eliminated beveling and grinding process, and it combines as beveling. It's automated plate bevel which directly bevels the part. And this is the secondary data collected from SME. This is the difference chart. By using the data, we analyze it completely, and by using the references from previously mentioned journals and textbooks, we got the time difference of 156.56 in hours for conventional and automated process. In that way, it related to profits and economy of the SME. It reduces many working hours, so the SME can work more faster. And this is a power difference chart. Even the power is a bit high in automated process, but all the other factors which are considered is completely varying. In the automated process, there is no gas consumption, so we can save around 577.03 kgs of gas, and overall it's 3.6 tons of gas saved for the data given by SMEs. And in the conventional process, we didn't got any reusable scrap. It all comes like sludge or powder. It can't be recycled. In the automated process, we can get the scrap in the form of chips, which can be reutilized, and this is the tooling scrap. In the conventional process, there are many grinding wheels and nozzles have been used. But in the advanced automated process, there are only some sort of tool bits which can be replaced it can work for a long time, which can make more work than this conventional process. This is the result we got from all the analytics, and by using all these references, we converted everything into carbon footprints, which gave the result of total 3,464 kg of CO2 have been saved. By adopting plate beveling machine at Trinitech infrastructures, we led to significant reduction of 3,464 kgs of carbon emissions. This research emphasizes transformation potential of circular economy in reduction environmental impact by enhancing SME efficiency. Thank you.
நான் ஒரு கரெக்ட் நான் ஒரு half an hour பேசி கால் பண்றேங்களா? ஆமாமா மீட்டிங்.
Next we have our footprint of mango pulp industry.
அது ஒரு 6.5 tons கிலோ.
Badya sir, Prof.Sadhan sir, and Venkateshwar sir, Krishna sir, Sai Sudhakar sir, and all other participants of this particular conference. Very good afternoon to one and all. I am very happy to present. I am Dr. Gulashwari, working as Associate Professor in Civil Department of History University, and my specialization is environmental engineering. And I have published more than 35 journal papers, international journal papers, and I authored 3 textbooks, and I got more than 7 awards up to now. Even best paper awards from different conferences also I got, and 3 students of PhD are pursuing under my lectures, and I guided 15 MTech students up to now. So thank you for giving this opportunity to present here. So as a part of project, international project going global, so one SME was taken, that is mango pulp industry. So carbon footprint of the total mango pulp industry I would like to cover today. So next slide. So these are my team of SVU. So Professor Varadarajan sir is a principal investigator, Divakar Reddy co-principal investigator, and myself also co-principal investigator. M. Rajshekar professor from Geology department also co-principal investigator, and Anil from PlanetWise is advisor, and Sadhan Kumar Ghosh are mentors for this project or work. So these are the contents I would like to cover today. That is introduction, literature review, objectives. Next. So already greenhouse gases nowadays we are caring a lot running the global warming. So whenever greenhouse gases comes into the atmosphere beyond limits, it leads to global warming. Climate change happens. So there will not be any proper rainfall in proper season like that it may take place. Malaria disease like that likely to spread. So what happens is whenever there is some carbon dioxide in the atmosphere, so it will allow the solar radiation from the sun to move to the earth. And whatever will be radiation that is reflecting back, so it won't allow to move with the second back to the earth. So because of that, it presents heat rising temperature. So because the wavelength of the sun's radiation, so whatever radiation but that is coming out from the earth is more than that of the carbon dioxide. So that's why it won't allow to go away. So which results in the action warming. The main reasons for that one is forest price conflict, eruptions, and man-made sources and like that. So that is combustion of fossil fuels like that. So we see that carbon dioxide that is not only carbon dioxide, we can get more like that. But who will represent as totally carbon footprint in terms of carbon dioxide equivalent. So these are the various things carbon emissions category was considered in order to calculate the carbon footprint of any activity of any industry or any educational institution like that. Scope 1, Scope 2, Scope 3. Scope 1 means where you can able to find direct emissions from the source. Scope 2 means indirect emissions such as purchased electricity like that. Scope 3 means indirect emissions but that is not borne by the companies such as the transportation of the employees or wet waste, decomposition of organic matter like that. So carbon footprint is one of the very important tools that is necessary nowadays to measure the impact of our activities on the environment and in particular climate change. So it relates to the amount of greenhouse gas. So that is actually produced from each and every activity of any industry or institution like that. So these are the Scope 1, Scope 2, Scope 3 categories. So literature will be based upon different experiments and new technologies. Most of the people have reduced the carbon dioxide emissions in their institutions like that, such as dairy industry like that. Next. So my present area, mango pulp industry, there is a mango pulp industry which is located in Renugutta. So their main crops are mango fruit pulp, yellow papaya, pulp, white guava pulp, pink guava pulp like that. So this is the location of the industry. Next. So this is the process that they are doing. They want to wash the fruits first and they want to remove the seeds from that one. They want to remove the skin of that one and they want to crush that one and make it to pulp. And they will store in some storage boxes. Next. So the main objectives of this project are work was to collect the data of Scope 1 category from the mango pulp industry and also Scope 2 category data of mango pulp industry and Scope 3 category of mango pulp industry and to calculate the carbon footprint of these Scope 1, Scope 2, Scope 3 category based emissions. So based on that we collected the data. So if we can be able to see here, so formula is there. So carbon dioxide emissions calculation for that. So for consumption of fuel, so it would be consumption of fuel into emission factor divided by 1000. So that is the formula that would be used here in order to calculate the carbon footprint, that is carbon dioxide emissions from the fuel consumption. So emission factor it will be different for different things. So here 2.65 is the that is feasible one for this calculation, that is vehicles which is having somewhat petrol, and 2.63 is to be used for the calculation of carbon footprint for the fuel diesel based one. So these are the Scope 2 emissions, that is generally Scope 2 emissions regarding purchased electricity, whatever the units of electricity that they have been consumed. So in that particular day or month like that, we can be able to collect and based on that we calculated the how much carbon dioxide emissions that will come based on this formula. Total electricity consumed into electricity emission factor. So here emission factor will be different for different areas based upon the grid type. We have to use corresponding emission factor. So Scope 3 in the similar fashion, number of cylinders that has been used, some may be having some canteens like that also used to be considered. So this is the table for the collection of data that we have given for the industry to collect the data. So regarding the type of vehicle, what type of diesel that they are using. So is it company gold one or not, like that. So even other cylinders, number of cylinders like that, we have collected the data. And when it comes to the results and discussion, so here direct sources of carbon emissions, carbon emissions from that industry is from mainly from the transportation, mostly involved. So most of the vehicles are both vehicles there. So in order to carry over the mangoes or fruits from one place to another place. So from that we calculated what would be the carbon dioxide emissions in the month of February, March, April, like that. We got about 31 tons based upon the formula that I had explained just now in order to know how to calculate the carbon dioxide emissions. So there is the category 2, that is direct purchased, there is purchased electricity, indirect source of the carbon dioxide emissions. So from the purchased electricity we calculated. So this is the 291 tons of carbon dioxide was bought for that one. And category 3 regarding the LPG cylinders are somewhat weight based like that. So 69.447 tons and 27.79 tons like that is the quantity that we got. So overall total emissions if we observe for the 3 months of February, March and April 2023. So these are the various values that we got, total of about 428 tons. So just for 3 months, just you imagine how much quantity of carbon dioxide emissions is going on. So based on this project and having some suggestions from the mentor, we have collected some CESIPs from the industry. So how they can be able to reduce by themselves without any amount from the project also, usually how they can be able to reduce carbon dioxide emissions. So they have been given to 3 points that they can able to do fastly so as to reduce at least 20% of the carbon dioxide emissions, such as the reduction of water wastage, reduction of process wastage, reduction of leakage steam in pipelines, leakage of fuel reductions like that. So the same thing that has been implemented by means of going through where actually the leakage is happening in the pipes like that. So as that was rectified by them some leakages and even wastages, the mango sticks that they are getting. So they dried up and they once again used for the boilers in such a fashion. So like that there's some usage of like that because of that some consumption of other fuels which is giving a lot of carbon dioxide into the atmosphere was reduced. About 20% of the total carbon dioxide was reduced because of these particular sustainable initiatives. About 28 tons was reduced. So this is the total amount of carbon dioxide equivalent emissions. Scope 1 31.5. The amount of carbon dioxide equivalent emissions scope 2 is 291.6. And total amount of carbon dioxide emissions from scope 3 is 97.6 tons. And because of implementation of the CES and the circular economy points in their industry, so about 29 tons of carbon dioxide equivalent emissions per month was reduced. So that's a great achievement for us actually. So based upon these project outcomes, so we actually interacted with SMEs and data collected, and we started the Ecolution Club. So in our college, so that is Ecolution Club with the principal as the chairman and myself as the faculty advisor, and 50 students has been researched and worked for this particular project to global, that is going global partnership project. So even we conducted some what you call presentations, what you call electrician competitions like that under this Ecolution Club involving the students. So where they enthusiastically participated in this competition, and most of the people got prizes. So and even my students are involved in the attending the workshop at Kolkata. My tech student, that is PhD scholars and our tech students. So even we conducted one workshop as a part of going global project in our SUCE, where about 50 students were participated and 10 members from different SMEs were attended to this program. So nice lecture was there from the planet-wise person, Anil. So who had given a lot of information regarding how to calculate carbon footprint like that, which helped us to calculate carbon footprint easily. So these are the functions. So the about 12 students of environmental engineering division. So engineering department did projects on the going global project, and the same thing we presenting here also. 4 of SMEs. So these are the students involved here in this project, PhD scholars. So Prakriti Suraksha Club is also started by Professor Badran sir in our college. And my profound thanks to Savan Kumar Ghosh sir, President sir, our Vice Chancellor and Registrar sir of SV University and UK British Council for funding us and helping us and encouraging us in doing this project. Thank you very much.
Next we have process modification and promoting circularity in FMCG industry.
Everyone, I'm going to go here because we have doctors such as Dr. Indy actually preceding me in giving presentation. Anyways, I'm a entrepreneur based from Tirupati, from Sri City. We have a manufacturing industry where we manufacture cottage cheese, more popularly known as paneer, on an industrial scale. So we were approached recently, about 6 months ago by Dr. Venkat. Thank you so much for this opportunity to see how we can be participant of this circular economy concept. So where we, thanks to this, we kind of went into a process, the process itself, and we saw how we can implement changes for how to save water consumption. The dairy industry in India typically has a lot of wastewater, which if it is not treated properly, can be a huge environmental disaster. So also, of course, this is circular economy. So we started with laying down our goals. We wanted to conserve a lot of water. We wanted to have a proper effluent treatment plant, which is treating the water properly. And while we were doing this, when we wanted to save the water and how we are treating the water and so on, we got into the very crux of the matter of the process itself. So if the water which goes into the process is saved, automatically the water which comes out is also reduced drastically. This is how we have so this has also helped us reviewing our entire process, which has helped us improve the microbiology of the product, because water if it is not handled very well, it kind of affects the microbiology of the product as well. So this is the typical manufacturing process of paneer or cheese, cottage cheese. So there's a particular method in which we do it on artisanal scale. We don't use any acids as well to manufacture a product. And so this is receive milk from the farmers, 50 kilometers radius. We are receiving raw chilled milk, and we process this into paneer on a daily basis. And we kind of mapped, we segregated our wastewaters into different streams. And so the processed water, the effluent which comes out, and also the waters which can be treated and so on. So we segregated different tanks and so on. And so this also helped us review our process a little bit more in detail. So the main problem is, the pollution control board norms, I think Madam will be able to second me. Every time there's water, every time there's a dairy plant, whatever milk is being consumed, 3 times or 4 times the water which is discharged. So we wanted to kind of review this. So there's a high water consumption in a dairy plant. And there's always, there's a scope for water efficiency. The industry will be profitable if we have a proper water management. And water recycling is expensive. The membranes are expensive in India. Whatever we say, they are difficult and difficult to maintain. You need proper engineers. You need to constantly monitor. They are expensive. So you have to come up with good strategies that the industry is profitable and self-sustainable. So what we did is, of course, while reviewing all this, cost was we are an industry where we have to make money for the shareholders. So we kept that also part of the concept where we have to have a lot of energy savings, which happens if we have good process. So the carbon footprint was my colleague Rajesh. Yes. So he helped me prepare this thing. So we are so of course saving a lot of water will help us cost savings, economic opportunities, energy independence, resource conservation, health benefits, and so on. So this is something technical which he helped me prepare. I think you'll be able to read them.
The recent process which have been followed before identifying the leakage areas, they have been following the old process where electricity consumption and free water and water usage process altogether produces about 123 kg of CO2 per year. After the process has been modified and the water is treated in a regular basis, the carbon emission has been decreased to 84.9% of per year. By which we can reduce about 30.97% of carbon reduction by comparing both the old process with the new process. So that we can achieve about 30.97% of carbon reduction annually. And it has been a positive environmental impact by implementing the new innovative new process in milk industry.
So what we did is we went about the process itself. We reviewed the cheeses which are made across the globe, part in mostly around Mediterranean countries and so on. And we adopted one part of the process which we implemented and we pushed into the paneer manufacturing process itself. So that helped us. We had to do recipe trials, a lot of recipe trials, and earlier shelf life of the product was about 15 days. Now we are able to move it to about 45 days to 60 days. Without adding any preservatives, just reviewing the process and implementing processes of other cheeses in the entire manufacturing process itself. So the microbial study, every time we did a microbial study, we have to wait for 60 days to get a final how the the E. coli or coliforms and yeast and mold counts and so on. So we had to wait for all this. So that's why we are yet to implement on industrial scale. We have managed to get this done on a lab scale, and now we are going to be implementing on industrial scale. This is actually the new process has made the taste, the texture, and the flavor better. We've given this commercial samples to the market when we've done lab scale models, and it's become better. It's enhanced the taste, the flavor, and so on, which is really that is why I'm really thankful to Dr. Venkat for helping us be part of this circular economy concept. So this is the microbial parameters which we had, and then what was the resources which were used earlier. So earlier we were using pre-processed water treatment. We had about 25 kL. Now we have to use only about 3 to 5 kL. Quantity of water used in the process was about 25 kL. We brought it down to 5 kL. Water and effluent treatment plant, automatically it comes down drastically. It's come down by 50%, which is a big thing for us. Manpower, of course, little manpower is saved, but more importantly, the texture and the flavor and those things have improved. Yield of milk is also improved. So when there's a proper process which is used, salt kind of holds on to the water. So that has given us a higher yield also. So we are more competitive in the market. So this also helps us. So the profitability goes up if the yield of milk also goes up. So these are the tangible benefits: water reduction, ETP handling, and reduced manpower. And intangible benefits, like I mentioned, space savings, better microbiology, improvement in texture and taste, and extended shelf life. Now, moment we have a better shelf life, we can reach out to larger markets. We are already, looking at setting up a unit in Singapore also. So these are the conclusions: water conservation, circular economy, resource responsibility, product quality enhancements, and it's a win-win sustainability for everyone. Product has become better, and the circular economy is also achieved. Thank you. And
thank you for the presentation. The floor is now open for a Q&A session.
If I also take a few questions from the audience if they are. The first paper. Any question from the first paper, which was A143? Coolant. Identification of the nuclear coolant or interest minimization. Any question? I would like to ask.
Vishwanath, are you there?
Yeah, available, sir.
Lola,
Yeah.
my question is, you said that you are using power. So how much power you are consuming per month or per day?
Actually, the coolant oil earlier we were using 208 liters per month.
Power, electricity.
Electricity we are using 160 kVA for some Mazak machine.
Are you purchasing power or you have any alternate source of power like solar?
No, we don't have solar. We are purchasing power.
Do you contemplate of having solar power? Because the main source of carbon emission seems, your company seems because of this electricity power which you are purchasing.
Actually, we are using the capacitor bank UPS. It will increase the more power factor. There we can minimize the power. So incoming power we can minimize. So that is the reason we put uninterrupted power for supply UPS there. One capacitor bank is there. So if mission is required 100 kVA on that, so real power it will not take. That capacitor will store the power and it will give the it will reduce the monthly units.
So this is part of the Going Global project where we have taken the objective only to focus on identifying the alternative to the hazardous coolant oil, and second one minimizing the hazardous waste generation. So these two scopes we are taking for the study. Now in the future, the extension of this DG project will be focusing on scope 2 emission. So that is the objective.
That's another question which I have. And I know this is still progress. Are you also into the material recovery? Just because you are trying to minimize that scrap and all those. Are you doing also that material recovery?
Yeah. So first of all, when there is a scrap material, nothing will go waste.
Yeah.
Each and every gram will be set for recycling because it has some commercial value. So that's why everything will go there. But whereas the hazardous waste, it has to be going for the secured landfill as authorized by the pollution control board.
But as you know, the landfill is also getting banned. So how do you see as a landfill as this solution about?
So right now, that is the only solution available for them or provided by the authorities. Maybe slowly it will move for installation because we have some calorific value also. Whatever the slide with some high color, we have some reasonable calorific value. Maybe they will be putting it in the mixing with the other chemicals and taking it for installation.
Okay, thank you. So we move to the another question of A158.
Audience?
Yes, sir.
So carbon footprint reduction in MSME manufacturing price approach. Yeah. Any question from audience? Then I have a question. So, for calculation of carbon emission, I think for power, you have shown that the emission factor is 0.85. Good. So, what is source for that? There is the data given by the Central Electricity Authority. So, based on there is a big document. Year on year, they will be publishing the volume of both, considering all the entire power sources in the entire country and coming to the number. So last year it was some 0.85 gram per kg per unit of power utilized. So that is a thumb rule that is universally followed in the entire nation. So that is the reference material. Central Electricity Authority. 7-1. Year on year, there will be a small change. Year on year, there will be a small change. That is correct. Six. Adopted circular economy, the evidence from kinetic infrastructure base. Any questions? I have a question. Speaker, could you? I have a question to come forward. So you said that you suggested to the manufacturer that going for automation is going to reduce the emissions, right? And you suggested that to have plate development. And also in your presentation said that having that also reduces the human error. Then it's not it's working time. Working time. When I said that when I'm going to automate, I would consider that automation means again it consumes the power, right? So did you consider that?
Yes, by using the specifications of the machine which are given by the manufacturer itself, we consider the power consumption in conventional process is average analysis of power consumption.
For automation, the machine some power.
Yes.
Once you automate, the power consumption may increase in fraction.
Yes.
So did you
yes, sir. The power has been increased, but all the other factors are it has made much difference. All the other factors in the conventional process, we use gas to cut LPG and oxygen, but in this automation process, there is no
gas is related. It does not power. That's the best for 166.
So you have solar one, right?
166 about the
Not adopting, yes. So have you understood like in the pre and post impact, like how much is the impact for like for pre and post, because you get a strong consumption.
Yes, sir. There is usually from economical side of assembly, that's completely different. But in scientific side, power has been increased with just 25 units for 3 months of time.
And you also have adopted this automated.
Yeah.
So can you just describe like what was your question in that? How do you do that?
Actually, for the measurement process, we need to level the edge and then we need to finish the edge. For that, previously, gas cutting is used. They used to cut manually by using gas cutting machine. They used to cut the edge.
And then they measure the impact by using the automation, because
in the automation, the machine directly reverses the blade. So there is no need of cutting them. We can directly remove the form of chips, in which chips can be recycled.
so is there is a minimum like waste material, so you have minimized the percentage of the waste?
No, sir. Actually, in the gas cutting, the waste cannot be replaced as it's in the powder form or some CRG form.
Any solution you are coming with that? Like when you say like cannot be utilized?
Yeah, I'll add to that.
Yeah.
Even I'm also contributed to this 20%. So the thing is, in the conventional process, whenever there is a operation,
Please come.
but in the conventional beverage process, the first step is to cut the material. In order to cut the material, they use oxidization or LPG plus oxygen or any other flammable torch technique they use to cut it. Now, in order to do that particular process, in the process of cutting, along with the metal, there is a plug or flag will be formed along with it. Now, when there is a flag or plug formed along with it, that metal cannot be reused or repurposed. it has to entirely go through the melting process, and then again the impurities has to be removed. That is the step one. Again, in the same conventional process, the step two is once the cutting is done. Again, in order to get that 45 degree inclination or 30 degree inclination, again it has to be surface grinded, or in some cases, some amount of plastics or some amount of other polishing technique has to be used. Again, level. Now, again, we need to use the abrasive part. When we are using abrasive part, the metal will also be removed along with the abrasive material mixed with it. Again, it is another amount of slag that is adding up to the metal material. Now, again, even in this case, the metal cannot be used. Now, once the once this is done, again, if there is any abnormality or the surface difference or deflection is there, again, the metal has to be choked off completely, and again, the process has to be repeated from the beginning. In the automated process, it's the other. We need not use any LPG or any other flammable metal to it. It is just a simple machining process. So, whatever the chip that is coming out of it, it is straight away that can be repurposed. All we need to do is we just need to collect the material, just like how we can collect it in the lathe or a lathe shop. This material, entire material can be collected, and it can be repurposed directly because it doesn't have any impurities other than the material. So it is like a virgin metal that is being soaked up from the application. So no impurities are being added up in the form of abrasives or in the form of welds or slag. None of the metals are being added as impurity to it. So that is the reason through automatic product, whatever the trap that we get, it is more like a virgin metal. So we get little higher price than the normal.
Okay, thank you. Let's move to this 192, right? 192.
Yeah, the other question is 192. Madam, you said in the presentation you are calculating, you said LPG is scope 3. So actually, where it is used? LPG cylinder? Can be. So can we consider scope 1 or scope 3?
Yeah, I was about to ask because especially scope 3 is a pretty challenge, all the time to measure, and if you saw the value, I think you have the highest effect was showing in the scope 3.
Company owned vehicles, companies based one is scope 1. Whatever may be.
Yes.
That comes.
So I was saying like in the scope 3, it was one of the highest value, if I'm not wrong, scope 2 or scope 3. So that was it, giving me certain thoughts in mind, like how do you assure like you have more control on that scope 3 than the scope 1. Scope 2 is highest, but scope 3 was high. Scope 3 was higher than the scope 1.
Yeah, can you please scope 3, can you explain?
Anyway, any opinion? That's fine. Overall, that was only the question.
Yeah, thank you.
Based on production capacity, we have to calculate the things, the power generation or weekend consumption, everything based on the production capacity. Electricity, based on the product, they are very.
Yeah.
We asked madam, but they have not given data. Without permission from Cheshkala Madam, Pollution Control Board, they are not only the.
That is always been a challenge with this country. I think that's.
Without permission, they give. Yeah, they will give. Actually, we.
Coming forward, the
Production quality also. They have given for that they are giving.
But can they work the third?
Because getting the data from all those people is not that easy at all. Yeah. Then you get into different domain actually. About the bigger research and getting to the more activists. Yes. Yes.
Big data.
Yeah.
the public domain data has to be given access.
So I think, because it's a going global project, it was more on collaboration side. So it has to be more on that. So that's the reason that they must be taking care of that, not challenging them.
They are afraid is, yeah, this may become global.
Yeah.
They make some
That's a good work.
Searcher interprets and how it presents, that gets represented. So that is what
Even I am not mentioning the industry name here. That I am not mentioning in PPT, industry name.
One question, ma'am.
They already told it should be confidential for some purpose. And
That can be done. That can be done, but they should share the data at least. Yeah, their name can be confident.
data regarding carbon footprint calculation, they have been given, but not production details.
So it's not easy to get the production data. So,
Understand. Should we, said about how they dispose the wet waste, because there's a lot of wet waste that would generate multiple industry.
Actually, they are disposing outside, sir. We suggested to decompose. Composting, that is implement the composting process so that we can reduce further carbon. They want to try it. They have to use some lining on the ground because further the penetration of water from the mango, they are polluting the water. So they are trying to line first on the ground. They want to.
okay, thank you, several times. Thank you. Good work. I think a lot of other people would be happy to interact with you to understand all this. Thank you. The last A157 about the process modifications. Just very simple question. We talked about yeah. You talked about you reduce the use of the water, right? Up to what percent like you have used, like you were able to reduce the water?
So earlier, so this is an estimate, of course, but on lab scale model, it will come down by about 50 to 60%. So
That's
earlier,
quite significant.
yeah.
What a change you made.
So this is used in some of the cheeses which have prepared in Mediterranean countries. They use a lot of brine water. Brine water is very good for microbiology as well. There's a lot of chlorine, chloride ions and so on. So we have started packing our product in brine water. So instead of letting go of that water, so it will require lesser water for process, and then you use that water to package your product. That increases the shelf life.
That's what is being supplied from. Is it supplies to you or?
Yeah, she supplies the water.
Not even any control, right?
No, we don't discount.
So then you must be happy now to yourself with your city water, right? Okay. How do you
Brine water is basically.
No, I didn't see that. But I mean, where are you taking? What is the source of the water? If not,
Water we get from industrial. We get supplied with part of the Sri City, so we get industrial water. Get water supplied.
Yeah, storage, rainwater.
okay, then water storage. Yeah, right. You are kind of using that TTP. I mean, treatment plant.
What
Yeah, yes, correct. So we are harvesting the water, then storing it, then when you have it taken to the treatment plant, then it's supplied back to the industries. That is the water we are using.
I think you said the country.
Yeah.
That you have to say that you have already done the lab scale production and the brine water you are taking and doing all this. Then please, but will it add to the cost or will it reduce the cost?
Like I said, it improves the yield, and the yield itself increases. So your profitability and yield increases.
So per unit cost will not increase, or you are saying yield is increased, obviously it can reduce the cost at a significant level. But will it be that because when you are doing it in the industrial level, will it be that flexible enough?
Yes, so we've done it on a lab scale model and then a very little more commercial scale model, but not an industrial scale model. Because you have to, You have to map your processes and then, implement, because you already have an existing production setup, which, so you have to modify that. So overall, what happens is you are saving a lot of water for process itself. You're saving a lot of pre-process water treatment. You have to do a lot of water treatment before you use it for process itself, because you don't want any microbiology issues with water itself. And then having done that, having finished the process, when it goes to the ETP, again you save a lot of power, because you're saving so much water, how much water you have to treat as well. So it has a significant saving.
So this is the whole testing process. Do you have any lab or people working constantly on this?
So I did it in-house, because then the technology also travels. So we've done it in-house. So till we capitalize on it, eventually I think India, this is the only cheese from India. I think everyone should adopt this, because we save so much water and so much environmental hazard to save.
Okay, just we take last question.
Cheese is everybody's.
Yeah.
So, stop writing for preservation of this your product. And so the water which we use that is a sterile, or because this may also incorporate the pathogen organism to your product also.
Yes.
So, have taken some.
It's a very valid question. So what we do is we do a water pasteurization. So in water pasteurization, not an expensive process. So what we do is we use a plate heat exchanger model. So what water, when the temperature comes in, when you heat it, and the same temperature you use it for, in technical terms, same temperature is used to cool it down and bring it out and so on. So very minimal consumption of fuel is required for pasteurizing your water. We use pasteurized water to make a brine that is used to package a product. Yes, packaging goes for a range, right? Because earlier you were not packing with brine, now we're packing with brine. So you have to accordingly adjust your packaging as well. So when your shelf life goes up drastically.
Okay, so thank you for all the presentation. I think it was a lot of learning from each of you guys. So we have seen, I think, going global project also helps people to understand the adoption of the circular economy, especially the Indian fellows. I think you have been calculating carbon footprint nicely so that you could see the reflection of the what you have done in the workshop and you are applying it. So that's a good part of that. And it's good to see you have been reflected and collaborated with the students that they have been helping with. And what when we mentioned about nowadays, I think looking at where we are talking about the circularity, the scope 1, scope 2, scope 3, somewhere we have to keep the top of the mind, how do you balance and you address it? Because then only we will be able to contribute more significantly in terms of the carbon emission, climate change, and all that. And about some of you guys mentioned about automation process. I think that is, we have to think about how the tools and techniques can be utilized in terms of the circularity. It's not only the best, it's that it will ensure it is like how do you develop a mechanism and system design which helps in the circularity. So thank you everyone, and hope you will continue this work and also collaborate with each other to make it more. Thank you. So some of you probably already know it, and I can add. Just let me also introduce a little bit because some of them may not be knowing. So we have Dr. Prof.Sadhan from Western University. And no need introduction, those were known to me. I think well known maybe in terms of the circular economy working area project. I think we are also a product of his initiative, the work is concerned. So thank you for coming and yes. Words.
Yeah, okay. So I'm not really presenting anything here. Yeah. I'm not making any presentation now. As promised, we will be discussing on going over project's outcome. We have all the partners, industry and academia. Let me just look at it and see that whether who are there and who are not really attending this, this discussion. So, Aspen University, from Aspen University, me and Dr. Krishna Bahadur, okay, from Jadavpur University as well as ISWMAW, Professor Ghosh, from ISWMAW, you are the only person.
Yeah.
Now, that's sufficient.
Sure, take the attendance. What from which institute?
Yeah, I think that that's the thing we are quickly trying to get that. Okay, SVU, then Gita, yes, Tom, City, yes, and now industry. You are there from industry, you are there from industry, anybody else from industry? Yeah, okay, so, okay, others are part of us. Make comment, you have heard, colleague presenting their work. So we would be trying to specifically get few points. My first point is all the Indian partners, we are the UK partners. Okay, we feel the project has improved awareness of each other's higher education system. Okay, so can you jot down few points or share with us on this immediately, and we will make a note. So Krishna, Dr. Krishna, my colleague is making a note. So what would be your reaction to that? Whether a project has improved awareness of each other's higher education system? If answer is yes, then how and what has been changed, what has been done? Yeah. Okay, please.
Yeah. It helps a Student University on two fronts. One is we could get an opportunity makers of students to go and visit these SMEs, and they could interact with the technical people and know the technology behind each of these SMEs, how they work. But also, especially the university students, then they've been confined to theoretical classes, which have been this specific project has helped them to go really and touch their skills. And the two most important things, it has opened the doors, to have collaboration with industries. We had it, but it has included a lot. To have collaboration kind of activity for everyone, and internship to send some students also internship to these.
Okay, good point. But one thing we have to really keep in mind, it's just perhaps in many cases we have done the light touch. Okay, we have to enhance that. So alongside, I will try to really think of, what benefits it foresee for India in terms of both in academia as well as in industry. The development of the proposed project, because you have given a light touch, you have developed contacts in many cases, but actual implementation of the project is still, a bit of far-reaching activities. Whether you will be pursuing that, and if there are any pros and cons, what is your reaction on that? Then also you need to really reply. Anybody other than Professor Bharadwaj, like to share on that? Yes, please.
Yeah. So I think one thing good we have seen in this project, certainly it has brought the people together, like-minded people, and which we can see like how we got into projects, and you can see that this conference we are working. I think this was also connection came through the project. That's why we are all together over here. So that's one. Second, as Professor Prasanta mentioned about like how we are seeing like foresee about that. So from the engagement management, we are taking at least few actionable, you can say initiatives. Specifically, I'd like to mention one. We are thinking at how we can bring to the curriculum, bring to the education. So we are trying to do it the way, for example, we would like to develop a program where we, for example, a faculty development program, where we will bring this knowledge to share, disseminate to other those in the people those who are in the sector, like in the education sector. So this is something one which will be launching somewhat. And second, even the students, the couple of our students, they participated when they come back, and now they are talking to many other students. And at engagement management, we are introducing the capstone project. So what is the capstone project is about, where the student will be working for than around 6 months or more with the one SME throughout. And we are also aiming to let them work for 1 year, and this will be the part of their master thesis. So instead of doing the master thesis, they will be doing the project with the industry. So we are also learning from the British Council project by developing the model of the industry academia together, and with the help of Aston University, which hopefully we will be able to do that. We are now, because in this project we had a bit of limitation of reaching out the SMEs, and we learned as a lot of challenges was there to reach out the SMEs, and what worked, what didn't work about that. So that learning we are making note of that, and we are developing a proposal is almost ready, where we will be taking more than around 50 or 100 SMEs, starting with the chemical industry, where we will be working for them over the period of time and look into the circularity economy adoption. Where we will involve at least about if she got around 50 and for the student we involve, I think 200 students will be utilizing. This is the way how we will be developing a community about it. So these are the few things we will be doing. So the research will be the one angle, bringing to the class, and we'll be developing a case study also, we will be bringing to the class, and just will help the people. So overall, that's what we are aiming. Thank you. Hello.
That it's nice that we had this chance to project for the last more than 2 years. And in the first project, we had the development of CE, and we could not implement it as a whole in any place. Because think of the real life situation. So my suggestion, like, one part is we install in some of the institute as a whole curriculum solution. The other part, let us do that immediately. Include the circular economy as a subject in some of the PD courses, and that is easier. Okay, immediately. I mean, from the next session onwards, we can do it. And that can be offered by 1 or 2 teachers of our group. I mean, I'm quite sure that Gita, ISWMAW, ISWMAW, at least this 3 institutes can immediately from the next session can start at least one subject separate. Thank you. Do you agree?
Yeah.
Is it possible from the next session? Excellent. So this is one outcome. The second outcome, what Sadhan was telling, that it's a little long-term project, and it will take time, approval from the university and all these things, plus expenditure and everything. So let it go ahead as with its own course of time. The third, we have learned so many things from these industries, the SMEs which work with us in pan India in many of the states. So we have to make a document on this. It is, I'm not telling out our report, what will cause it is, but as a case study document from as an outcome of our program, this project. Let us take a target of by March 2024. Each of the institutes related to the SMEs, please prepare the case study, photos, data, the procedures, how it has been, and what was the status in the month of February 2023 or March 2023, and what is the status in December 2023. So this will be a very good impact document for us from our project. So this is the second proposal, which we need to finish by March 2024. And I'll request 4 persons to monitor this. Number 1, Sai Sudhakar from Gita. Number 2, Venkat from Sri City. Number 3, Varadarajan. I'm not. Sorry. He's a good friend of mine. I was just joking. And number 4, Dr. Osita is Dr. Osita is from ISWMAW. This 4 person will be responsible for getting it published by March 31st, 2024. These 3. And you know that we have a top-up grant where ISW and GITAM is involved specifically. But you all will involve you all. Okay. And we will continue this. And definitely, we will also apply for other funding. And I'm very much confident that if we apply, we'll get it. These are some of my submissions.
Okay, quickly about UK's part of it. Krishna, would you like to reflect quickly about UK? So mainly covering that, what benefits we foresee. Okay, I will give you the pointer because as a university in the UK, we emphasize on the impacts. Okay, research should not only produce research papers, but also it will really contribute to the society. So, Krishna can explain the things a bit, in detail, as well as something what he thinks about how this collaboration could really bring benefit to the UK higher education, specifically as the business.
Thank you, Professor Sadhan. For those of you who didn't see me in other presentations, I'm Dr. Krishna Bhatt. I work with Professor Sadhan after the university, and I'm a lecturer there at the university. So I've been associated with Professor Sadhan for quite a while now, and we have been working with several organizations within UK, outside UK, and several academic institutions also, mainly in African region, okay? Especially to start with countries that are lower to middle income in nature, such as Kenya. So they face similar problems because they are in the same growth path as previous India was maybe a decade ago or even further on. So we see similar challenges and many countries coming up with this agenda on a pressing note to implement certain to combat climate change. So this is going to be something phenomenal in the coming years, and we are going to be doing this more and more on daily basis. As governments set forth or set sail to reduce their carbon footprint as a nation, and are embarking on the agenda for net zero by 2050, 2070, and especially developing economies, the pressure is high. So this is on the forefront of agenda, not only for the regional economies, but at the national level. So that's the fundamentally important point we need to all note, and that why our gathering is so important. Secondly, Aston University has been collaborating with both academia and industry, especially if you look at the last few years of Dr. Sadhan's work and the close convention because the goals also has been very, very interesting for those who are really looking at practical impact on what research can translate to actionable insights we have managed to publish, not myself, but published in top-notch journals, which have been very heavily referenced or cited by other scholars about how SMEs are at the heart of this transformation from what was a very highly carbon intense industry towards net zero. So you can refer to all of that work, which should be very topical in nature and which should be very revealing for those of you who want to be scholars. And I'm looking at the students of ISWMAW here who want to be scholars or enthusiasts or practitioners in the industry, working in areas of circular economy and sustainability. This work, these papers are very relevant. Okay. Going global partnership has been very interesting. I was working with Professor Prashanta closely, developing a poster which was recently displayed in an event in Delhi. Yeah, it was a major event, I think.
Which is council event.
Which council event? Have you attended this? So
No, I got all of it.
Right. So it was attended by many dignitaries and it was attended very successfully. And the poster was presented and we got a prize also. What I learned from that was the impact is very spot on, very, very tangible, palpable on many levels, especially on academic level. We touched around 100 students directly through this program, through 6 institutions. And secondly, that is the direct impact, but the indirect impact is very far-reaching. As we develop content, material, especially teaching and learning material like case studies, it stays, right? It is for next generations. Even after you pass out of your class of 2024, it remains with the institution and people who come after you will learn about it. So there is no number we could put on, but it's not quantifiable how many people will benefit from it. This is our intangible impact. So hundreds, if not thousands of students will benefit from it. That's one thing. Secondly, number of SMEs have come forward to join hands in this effort to understand their own emissions and reduce it, okay, which is what we are seeing today. Quite impactful, topical, and also so kind and nice of these SMEs because it's a burden for SMEs to embark on this idea. Why would anybody want to? They want to rather maintain status quo. It's an additional investment. Okay, that's how we see SMEs who are crunched for resources and money. So this is going on a 3-pronged approach: academia, practitioners, and entrepreneurs who are taking this back on and moving forward in meeting the agenda of circular economy. So going global, we managed to achieve it to some extent. With the top-up grant, we are going to revisit some of these institutions. I'm joined by Professor Sadhan, who has been instrumental in our efforts also, especially when we wrote for Going Global Partnership. They were very quick to get back to us and provide their support, including Professor Ghosh. And we want additional funding to go and meet students in 3 institutions: Pittsville, Goa, IIM Nagpur, and IIM Shillong, whom we will be visiting in January and taking this agenda further forward. Mainly this time, we are looking at collaborating with local SMEs in that regions, because if you look at the geography of these institutions, they are spread across the country. One in the far east, one in the center, one towards the west. Okay, and this will take shape in the future also as government, decides to bring this agenda at a national level to reach out to many institutions. So there are opportunities to collaborate with us. Write back to us if you have any interesting details. And one thing I noticed since yesterday is, I predominantly come from UK background. I studied my master's there. I have a bachelor's degree in mechanical from JT, Hyderabad, and then I did my master's MBA in UK and my PhD in UK. So my outlook is outside in when I came to UK. So I'm coming from UK lens and looking at it through UK lens. It's not different, very honestly speaking. Engagement is not different. The numbers that we generate here are not different. In fact, the impact is more in the UK if you look at the numbers. But what is lacking is the way we write about it. The refinement in the way we write about these things. I would really highly encourage everyone who presented here to find an avenue to publish this work. Come and see Professor Prashanta. Ask him if there are collaborations, opportunities for collaborating with him to write about it. Okay. He will be very, very helpful with guiding you to write about it. No matter which journal, he can provide you such narrowed down focus that it will be very easy to publish. Okay, so if you don't manage to get this up to that level of publication, then all of the effort you spend will be going in vain. Nobody will look at this work tomorrow because it's not in the public domain. It's not scope of text. So I think that's one thing I wanted to say. So very interesting and palpable change has happened through case studies or action research, which is very value added to all of these efforts. Even for British Council or other funders like Department of Science and Technology to acknowledge your work, it needs to be the public domain. So on that note, I would like to end this, but it's been such a pleasure seeing you all. So yeah, I leave it to you. Thank you very much for all of your cooperation. And just want to see you again.
Just I can add one thing before you go. If you go on the ground floor, you will be seeing we have the sustainable development goals like photo booth. That is what we made under this Going Global project. Partner names are there on the bottom. We'll be able to see. And make sure everybody take a photograph for also because you have to motivate other people. And this is something like how we have to do the community building. And yeah, thank you so much. Sure. So it is our British Council, and we have informed them also we are doing it. They were supposed to come today for this, but was on the yeah. Yeah, I think that's one with all the partners will go there. Yeah.
Thank you very much, Krishna. So my last point, what I would like to really get a quick reflection from you all. What Krishna mentioned about the research. Okay, there are 2 points I need to really get from you. One is your idea of undertaking further research, which area you like to really do in collaboration. Okay, it could be the collaborating with the existing partners. Okay, like you collaborated with ISWMAW, the other universities to get this conference done on that. Similar sort of thing in the research. Okay, you mentioned about the Spark call is open. DST, UGC are funding. Okay, and there are British Council funding, definitely Royal Academy of Engineering, become and Aston is something. So what is not the first one? Think about futurist. What are the things you think that you could work together? We could work together. And the research team. Okay, so there are 2 columns that I need to really fill it up. I'm emphasizing on the research report, but that means I'm encouraging you to really come forward with ideas so that we could really we could work together in the course. Okay. So what I would suggest that get me those points, even the industry people. If you think that okay, that's the research, you want to really get it done by the academics. So you contact and get this thing sorted. So we would be in a position to take it from there. And don't worry about the funding opportunities and that. There are plenty. We need to really have ideas. Funding is available. If your ideas are good, you will be able to really get them. Let's quickly hear from you guys. Anybody like to really share any research paper that you would like to work on? Sorry.
So, good afternoon, everyone. So, my name is ISWMAW. So, yeah, I mean, it's opportunity for me to talk. As a result of this global project, we got 2 actually new initiatives eager to start actually. One more good news is like it's the center of circular economy of access. People research paper. So the 2 new initiatives we are going to start is we are exploring circular business model and how can we actually incorporate, because we are talking a lot about implementing circular changes, process engineering, etc. So we want to bring in the finance angle, the cost benefit analysis or sensitivity analysis. Mr. Madam has presented initial thoughts yesterday. So we want to explore that angle. So of doing this because sometimes we also need to evaluate the efforts which we are putting in these projects, what's the investment and how to actually maximize that or outcome. Right? So that's one initiative. And the second one is we want to explore the green metrics. Evaluate both the inputs and the outputs coming from this process. So these are the two areas I think I still feel they are untapped to the extent good. So that's it. These are the initiatives.
Thank you. Anybody else, have you anything to share?
I come in both, I mean, it's a, very hybrid kind of thing. I have my own SME and I also work with the university. So, yeah, I'm an entrepreneur. So, going global has really helped me to look into the insights of it and it has really brought me new perspectives of it. Not just going global, I would like to collaborate with more number of opportunities to explore this sort of things to scale up my revenue. Because that's where I can create more employment and that's where I can create more impact and that's where the driver lies. So when I started cricket tech, I now know that is part of the circular economy. I now know that there is a huge potential which can be exploited and it can be scaled into masses. So when I came to this conference, after interacting with more number of people resonating with the same ideas in a different direction from different corners of the world, I feel that this is a very innovative way to reach out to more number of people and more possibilities to unleash.
So what is the future? To be able to continue involved with.
Yeah, so
It's
one definite thing that I would like to focus on is we would like to write more number of proposals in order to exploit more technological avenues to scale up the initiatives of converting biomass into useful number of products.
what I would request all of us that, as for example, from Gita, you can decide from SVU, not SVU, SVU is like for the SVU, that what are the forthcoming research that I need all this information, very, black and white way, and you can deal with CCD part of it, okay? What are the other also this thing from Gita, from Kirisumani, Satyendra, you could deal with that and I think that respecting industry contacts, you must contact and get their views. Okay, so we would expect the things by tomorrow Saturday, so that I can, while I go back, I can process that and I can hand over to British Council. This is very important to create, to keep us motivated for continuing the work and also informing British Council. Okay, and there are loads of opportunity of getting further bonding and working together. But if we are not interested, no point. We will, and both Krishna and I from Aston University, we do not need research paper, research project, and that. To be honest, okay. So we can continue working with whatever we are doing there. Why we are here is basically you have given a bit of work from your side to get us engaged. And we like to really contribute to India. Aston University will never say us to work here. We can work there also. Okay, I would say that we love to really work with you. And this is our pleasure. But if you are not really interested, tell us that okay, it's not working. Then we'll not waste our time and we will not waste your time. But I'm sure that what I've seen from my last 20 years of working in the academia, I'm constantly, engaged with academia here in India. Although I have big portfolio elsewhere also, but I've seen that I get enough pleasure to work with you guys. I learned a lot, and it helped us to really go around. Although while I was in Indian Oil, I had the opportunity to roam around the country, understood it. I studied in West Bengal. I lived there for many years. Okay, my engineering was in Jadavpur University, so I didn't come out of that. But while I came out, I found that there's everything to really learn. And that happened while I was in India. But while I moved to Aston University, I found that I could really learn more about, India through these projects. I get engaged more. Okay, well, I never regret leaving industry and moving into academia. Many people ask me that, do you regret being in the academia? Are we getting less salary? Okay, but I would say no, I don't regret. I really enjoy every day. I share with, Krishna, my young colleague, and I would say I would love to really work with you guys and continuing that. I thank to all of you that you have put so much of effort in this project. Okay, and I did that, I would say. I couldn't really contribute much in this project because I was struggling about with the post-COVID. All the project was coming to the end. All of my European project was coming to the end in the early this year. Otherwise, we got the project. But Professor Ghosh came forward, stepped in and told that I would be managing everything in India. You don't have to really worry about it. But you have cooperated a lot. And we had a series of meetings, and I've seen that all of you have attended this. I could really see that you all are here. It's a very busy time, end of the year and all. And you came and you spend your time here. Okay, so please continue with that. But as I said in another presentation, that no research is a research unless we publish. So we got to really think, we mix the academic people, like, there are a number of academics, top-notch academics here. So we got to take that leadership of writing the papers. We can't expect that the industry people would be writing the paper. We could take their name also, and we would be writing the paper anonymously. So your companies will not be really named unless you want them to be named. We will not do it, but that would be an enormous benefit for all of us. Okay, and it will be learning for the early career researcher how to write a paper from a completed research project and how we are articulating the research questions and that. So let's give a go. Let's come out with the paper idea first and start working on. And you will get full support from us, that means from Aston University, to carry on. But you have to do it. Okay, don't expect that, and well, I've seen that working in a common research paper and that we always, if we think that others will do it and I will review it, then things will not work. And if you think that, okay, I will do the work, if even I do not get help from others, still the things will happen. Then only your paper will be there. Okay, so that's my experience. So let's conclude, our discussion here. I think.
And just I want to add a good example. Sometimes we are experimenting with our student. For example, one student is taking our MBA, Shreya, working in the Going Global project. Themselves, they have SMEs in family. So rather than taking the SMEs out, they are working on their own family business about that. So that is also the kind of impact, we need to bring in the system about that. And they are on the cotton. Just like to maybe talk about what you are doing with your industry and what was there.
Good afternoon. So the industry is about cotton gin pressing factory. In the bar, the raw material is cotton, and then we gin it. Like we separate the cotton seeds and cotton lint, you say, lint and cotton seeds, and then we sell the cotton seeds, the oil mills, and we sell the lint to the textile mills. So here a lot of waste is there, like in our industry, in our SME. So I attended the lecture, the sessions in Kolkata, which really helped me to apply this in our SME. So yeah.
Very good. Thank you. So these are kind of live cases.
Would you like to say something?
Last, I think we have to. We want
You're sharing some part of the academicians from universities. So probably next time, I think some party, that would be giving good results because they will show some interest in that work with us and at the same time, it's not concentrating only on carbon dioxide. What are the problems that they are facing in production? So that let them give that particular point where that's what we will give some solution where that our experts and we will use it then.
We had the